All right, philosophers. Introduction to Logic, Part 2. That should say categorical syllogisms, not categorically. I'm not sure why it says that, but I'm not fixing it. I'm lazy. All right, what we're going to do is review those 4 types of propositions that we talked about last time. Type A, all A is B. And remember, when you're looking at these things right here, the A and the B right here, these are kind of like variables are in math. So they're going to stand for terms. The term here is trees, and the term over here is green, right? So all A is B, all trees are green. And here is what they call a Venn diagram, diagramming the Venn. I don't know what that means. Type E, no A is B. So, for example, no trees are brown. You can see all trees are outside of all brown things, right? Type I, some A is B, some trees are big. And remember we said we're talking about, let's see if this thing works tonight. It might. Yeah, it works. We're talking about this area right in here. We know that some trees are inside of this some big things area, right? That's all we know. We're not saying that there's some trees outside of it. Maybe there are, maybe they're not. Maybe there's some big things outside of the trees. Maybe they are, maybe they're not. I mean, you and I both know that there are small trees and there are big things that are not trees. But based on this proposition right here, that's all the proposition is saying. And then finally, type O, some A is not B. So here we're talking about everything outside of, oh gosh, I can't draw to save my life. Everything outside of this whole area right here. Oh gosh, and I even got in this area. So basically, when we say some A is not B, we're saying all this is outside of all of this thing. Now, why is that important? We're going to talk a little bit about distribution right now. Distribution. What do I mean by distribution? I mean when we're looking at these propositions, right? Sometimes the term, you will know everything you need to know about that term in regards to the other term. And sometimes you won't. So, for example, an all A is B. All trees are green. Now, based on this sentence alone, based on this proposition, alone, I know that all of the trees are inside of the category of all green things, right? So I know everything about A in regards to B. I know it's totally in there. But are there green things that are not trees? Yes, but this sentence doesn't say that, right? This proposition doesn't tell you that. All it tells you is that all the trees are inside of all of the green things, right? So we will say that in these type A propositions, the first term is distributed and the second term is undistributed. All right. First term is distributed because you know all of A is inside of B. Second term is not distributed because you're not sure if there are any B outside of that A or not. Maybe there is, maybe not. Based on the proposition, again. Remember, not based on what you know. You know that there are green things outside of trees, but based on this proposition, that's all you know. Now, type E. Type E is a case where both terms are distributed. Why? Because when I say no trees are brown, it's also the case that no brown things are trees, right? We're saying that never these two will meet. So, no A is B, both terms are distributed. You know everything you need to know about A in regards to B. What's that? That it's all outside of B. You know everything you need to know about B in regards to A. What's that? It's all outside of A. So no trees are brown, both are distributed. When you get to the sum A is B, remember what I said. All you know is that there's some overlap. You don't know if there's some non-overlap. You don't know on either side, right? So you don't know if there's anything out here. So these are actually both undistributed. Right? There might be trees that aren't big. There might be big things that aren't trees. You don't know based on this sentence. And finally, typo. Oh, this thing is so heinous. I don't know if, let's see. Oh, good, there's an eraser. Oh, wow. So this thing is, we are talking about A being outside of this sum A, right? We know it's outside of all of that B. But we don't know if there's some A inside of all of that B. So the A is undistributed, right? Oh gosh, that's ugly. The A is undistributed. Is the B undistributed? Well, this is kind of the weird thing because we kind of are talking about all of the B. You know, all this B is outside of this section of A, right? So B here is distributed as well. I know that's kind of hard to see, or it might be hard to see. Um, that's the best I can explain it. If you need help remembering that, here's a little table. And if you need help remembering that, one good way to remember, the top three seem to be pretty self-explanatory. It's pretty obvious, right? Distributed, undistributed, distributed, distributed, undistributed, undistributed. And the last one, O, is basically the opposite of all these other three, right? Undistributed, distributed. It's the one that is not the same as all those. Why are those why are these things important? Why are we talking about them? Because we don't want to just make propositions for fun, right? We want to make propositions because we want to, in philosophy, we want to make conclusions, right? We want to reason from things that we know, propositions that we know, to a proposition that we don't know yet. So, for example, if let's say I know that all humans are mortal. Let's say I went out and I looked at all human beings and I saw every single one of them was mortal. Excuse me. And let's say I looked at Socrates, right? And remember, Socrates is a human. This is a type A, right? It's like saying, it's as if you were saying all Socrateses, right? Which there's only one of. I don't mean every piece of Socrates. I mean all of that one Socrates. So Socrates is a human. Well, if I got these two propositions, I can actually get a third proposition. Therefore, Socrates is mortal. How do I do that? Well, here it is. Well, there it is symbolized. Here it is in diagram form. Because let's say you say all humans are mortal. That's to put the category of all human things, everything that's in the category of human, inside of the category of everything that's mortal. Now, and remember, we don't know if there's anything outside of that, in the mortal that's outside of the human. All we're saying is the whole human category is contained in the mortal category. And then the Socrates category, which contains one person, we're saying with this proposition that that's inside of the human category, right? Maybe there are more people that are humans. Maybe that Socrates is only one. Based on this proposition, that's all we know. Socrates is inside of the human. Now look, there's no way for Socrates to get outside of the human category, right? So we know Socrates is inside of the human, and every little piece of human is inside of the mortal. So based on those two facts alone, we can figure that Socrates is also inside of the mortal category. So this is what a categorical syllogism is. Categorical syllogism is where you take two propositions, two categorical propositions, the kinds that Aristotle showed us about, right? You take two of those and you draw a new proposition that you didn't know before. And you could symbolize these. You symbolize each one of the terms, put them in their format, symbolize the term. So, for example, all humans are mortal. That symbolizes all H is M. Socrates is a human. All S is H, human. Right? Now, notice, of course, just like in math, you got to keep your variables the same, right? All H is M, all S is H, therefore all S is M. Now, this is something that I will talk about more in the next video when we talk about logical fallacies. But one thing to notice is that in this setup, right? Every time you set this up, what you have to have is a major term, a minor term, and a middle term. I forget which one. I think the major term is this one. And I think the minor term is always this one, like in the conclusion. I can't remember which one. It doesn't really matter. What matters is you have whatever's right here, right? Whatever is the predicate, whatever is the second part of this conclusion, has to be up here somewhere. And whatever is in subject has got to be in the other proposition, right? And then you have to have this middle term right here. Right, so, and notice the middle term is here with the major term, the middle term is here with the minor term, and what you do is, it's kind of like have you ever seen The Magician? He's got all the plates and stuff on top of top of a table and tablecloth, right? And he whips the tablecloth out, and then all of a sudden the table and the plates are all connected, right? That's kind of what this middle term is, right? So like if you look over here on this diagram, you have Socrates, human, mortal. We said Socrates was inside a human, human was inside a mortal. Human is the middle term, and if you took the human category out, you'd see Socrates inside a mortal, right? That's what a middle term does. So you take it out, and all of a sudden you're left with these two terms being connected. That's kind of like that was Aristotle's big insight into this logic game. All right, we're gonna do a little practice now, just like we did the last video. We are going to I'm gonna show you something. I want you guys to pause the video, try it yourself, and then unpause it and see if you got it right. Let me see. If you hear super loud motorcycles, that's because we are doing this in my house, and yeah, and of course I do this all the time, so I totally know what I'm doing here. Yeah. Come on. Alright. Almost there, guys. Almost there. Ta-da! Right there. Alright, so here's our practice. I did this because I kind of need to be able to write. I just, well, because I'm lazy. I didn't want to type it all out. Here's your practice problem. So practice 1. All scuba divers are swimmers. All swimmers can tread water, therefore all scuba divers can tread water. So what I want you to do, symbolize this in the way I showed you right here, like this. Take this and make it into that, and then also make this into that. That doesn't look like anything, does it? That's supposed to be an arrow. It's not. Apologize. Alright, so number 1, go ahead. All scuba divers are swimmers. All swimmers can tread water, therefore all scuba divers can tread water. Alright, so let's symbolize this. All scuba divers are swimmers. Now, right off the bat, you can kind of see scuba divers and swimmers both start with S's. A lot of times it's nice to symbolize your term with the first letter so you keep them straight. Obviously, we can't do that here. So scuba divers, I'm going to symbolize with a D. I'm going to say all D is, and swimmers, I'm going to say S, right? All D is S. All divers are swimmers. All swimmers are water treaders, right? So I'll put a T. These 3 dots here mean therefore. I should have told you that earlier. Therefore, all scuba divers are water treaders. So what does that look like in picture form? Let's see. All D is S. All S is T. Oh, get out of here. All D is S. Looks like this. Divers are swimmers, and all swimmers are water treaders. Right? There it is. So that's what your first one should look like. Go ahead and try the next one while I erase. No dogs are felines. All cats are felines. Therefore, no dogs are cats. So we need to erase all this stuff. Alright. Here's how I'm going to symbolize this one. No D is F. That's a type E proposition, right? All cats are felines. All C is F. Therefore, no dogs are cats. Therefore, no D is C. And here's how you symbolize it. You have your D over here, your F over here, and the next one, all cats are felines. All C is inside of this F. So now you can kind of see these two are separated, right? So you're going to know that no D is going to be inside of the C. That's number 2. Go ahead and do number 3. All right, number 3, some philosophers are teachers. Some P is T. All philosophers are people. I got myself in trouble again, right? Because I have 2 P's here. All P is, I'm going to say people is E. Therefore, some people, some E is teachers, is T. And so how does that look like? I say some P is T, right? We're talking about this area right in here. Some P is T. All P is inside of E. Right? So that's what it looks like there. So some E is inside of T. Now notice, like, remember we said we don't know about this E outside of the P. We're not sure if that exists or not, right? But based on this proposition. But you could see, like, this part of the let me point it out. I'm pointing with my finger as if you can see that. So, you can see this part right here is E and P overlap, right? So you know that E overlaps with T2. Go ahead and do the next one. Here we go. All logic is boring. All L is B. This problem is logic. All P, all this problem is L logic. Therefore, all of this problem is boring. So let's try this. All L is inside of B. All P is inside of L. Therefore, all P is inside of B. Alright, go ahead and try the next one. Alright, some St. Margaret students are not in lower school, so, oh, no, I'm going to symbolize this first, apologize. Some S is not L. Oop, L, I said. All lower schoolers are under 12. All L is, let's say, U under 12. Therefore, some S is not U, is not under 12. So some St. Margaret students are not in lower school. We are talking some S is not in lower school. I'm going to highlight. We're talking about this area right in here. Some St. Margaret students are not in lower school. Are there some St. Margaret students in lower school? Based on that proposition, I don't know. Happens to be the case that there are lower schoolers, right? All lower schoolers are under 12, right? So let's see here. You know what? Some St. Margaret students are not under 12. This is, does this make sense? Some S is not U. You know what? This doesn't make sense. Actually, this is an error. And the distribution thing is exactly where it comes in. And let me show you. So some S is not U. I could say like this, right? All lower schoolers are inside of the under 12 category, right? There are other under 12 people, but all lower schoolers are inside of the U. I could draw it that way if I wanted to, but I don't know how big this category of U is, right? I mean, all I said is that there is all of the L inside of the U. I didn't say how many under 12s there are. There could be everybody in the world that exists is under 12. I'm not sure. It happens to be the case, you know, that's not true, but it could be, based on this proposition, it could be like this, right? You could draw it like this. And in which case, some S is not U is false, right? There are no S that's not U. So this is faulty. And when I say the distribution is the problem here, here's why. Because when you say all L is inside of U, U is undistributed, right? And what I meant by that is you don't know everything about U that you need to know in regards to L, right? You don't know how big or small that U is. That U could be just totally encompassed by the L, or the U could be massive, right? Based on this proposition, you don't know. Whereas down here, some S is not U, U is distributed in the conclusion, right? You're saying, I know everything about U I need to know in regards to S, right? I know exactly where it is. All of U is outside of that some S, which if you don't know everything you need to know about U up here, you don't know it down here. You can't get it in the conclusion. So this is wrong. Chico, I'm sorry for doing that to you guys. But I guess it's good to leave it on there just in case you guys, or so you guys can see that mistake. And we'll talk more about what that error is. We'll talk more about that in the next video. All right, some apples are sweet. I'm almost positive, by the way, that there's no more errors. I think I saw that error before and I forgot about it. All right, anyway, all apples are sweet. Some apples are Fuji. Therefore, some at Fuji are sweet. All right, symbolized. All A is S. Some A is F, Fuji. Therefore, some Fuji is sweet. And that looks like so. All of A is inside of S. Some of A is inside of F. I'll draw F like that. So some F is inside of S. So we know all of A is inside of this S, right? And we know also what we're saying. Can I get different? Yeah, I can get different color. Good. Also, what we're saying is some of this A is inside of F, right? That right there. Well, so all of A is inside of S. Some of A is inside of F. So that same sum of A that's inside of F is also inside of S. Sum F is S. There you go. Go to the next one. All right. Some merchants are pirates. All merchants are swimmers. So some swimmers are pirates. Let's try this. Some M is P. All merchants are swimmers. All. Oh, whoa, whoa. What's going on there, buddy? All M is S. Therefore, some S is P. All right. So let's symbolize this. Some M is P. And remember, in this, we're talking about this guy right here, that little action right there. All of M is in S. All right. So there's S. And remember, in this, we're talking about all this M, right, including that action right there. So some of that S is inside of P. All right, going to the next one. How many do we have? Three more to go. All swans are white. All S is W. No cows are white. No C is W. Therefore, no cows are swans. No C is S. So all swans, all S's are inside of the W's. No cow is inside of the W. So we know no cow is inside of the S. No cow is inside of the swan. Easy peasy. Go to the next one. All right, a little more difficult. All men think only about sports. All M are sports only thinkers. A man called Gary is thinking, so all of G. All of Gary is a sport thinking man, a sport thinker. Therefore, all G is. Wait a second. All a man called Gary. No. Sorry. That's wrong. What I mean to say is, all men thinkers are sports only thinkers. All Gary is a man thinker, right? So all Gary is a sports thinker, a person that thinks about sports alone. I know the words I'm using barely make sense, but it makes good logic just to set those guys up. I mean, really, it doesn't really matter the way you say it. It's just the category. Are they in the same category? And the categories here, men who think is inside of the people who think about nothing but sports. Gary is inside of that men who think category, so Gary's also inside of that think about sports only category. All right, finally, this is the tough one. Everyone present today is employed at the university. This is going to test your skills from the last lesson. Everyone present today is employed at the university. Every member of the organization is present today, so every member is employed at the university. All present today. Everybody present today. All people that are present today, we'll say P, is people that are employed at the university. E. Every member of the organization is present today. All M, members of the organization, is P, present today. Therefore, every member is employed at the university. All right, so how does that look like? All P is E. All M is P. So then all M is inside of E. There you go, done. All right, now we're not totally done with we're done with the practice, all right? But there's one last thing I want to show you, which is, look at this categorical syllogism. All donuts are made of lettuce. Apple fritters are donuts, therefore apple fritters are made of lettuce. All right, now when you look at that, let me symbolize that out for you. Actually, let me go back to here. All, what does it say? All donuts are things that are made of lettuce. All apple fritters are donuts. Therefore, all apple fritters are made of lettuce. Now notice this. Is this set up correctly? Yeah, it is. All D is inside of L. I didn't draw this well. Here we go. Apple fritters, little tiny guy. All apple fritters are inside of donuts. Therefore, all apple fritters are inside of lettuce. Things made out of lettuce. Notice this is set up correctly. This is a correct deduction. So why doesn't it make sense? Well, because one of the premises, one of the things that you use to get to the conclusion is false. All donuts are not made of lettuce. In fact, no donuts are made of lettuce, right? So even though this is set up correctly, because the conclusion is false. Why? Because a premise is false, right? So there is a difference between truth and validity. Truth is whether the individual propositions correspond to reality or not, right? So when you look at these propositions right here, these three propositions, your question is, are all three of these true, right? Now they may not be set up correctly. They may not be set up and we'll talk next lesson about ones that are not set up correctly, ones that are fallacies, things that don't, things where, or syllogisms where the conclusion doesn't follow from the premises. So for example, I could say, right, my hat is blue, your hat is red, therefore his hat is yellow. Those might all be true statements, true propositions, but that's not the conclusion doesn't follow validly, right? So truth is whether those propositions all are the way reality is. Validity is whether you've set them up well, right? So that one, like the example I just gave you, was not valid. Soundness is when you have the two premises that you're using to get to the conclusion is true. The whole thing is set up correctly. Then you know the conclusion must follow. That's soundness when you have truth and validity. That's all we're going to say. And I will talk to you in the next video. Adios.